Example 34, water flows at the rate of 25 cubic meters per second in a trapezoidal channel having a base of width 3 meters, depth of 1 meter, and sides sloping 4 horizontal to 3 vertical. If the canal is lined with concrete with roughness coefficient 0.013, determine the depth after the jump, the Froude number, and the percentage dissipation. This percentage dissipation is simply head loss divided by specific energy at section 1 when their initial energy. So that's the percentage dissipation. Head loss divided by specific energy at section 1 times 100%. So that's the section. Let's solve for x. And the formula for hydraulic jump is F2 minus F1 equals Q times density quantity V1 minus V2. So x as to 4 equals 1 as to 3 at section 1. So x is 4/3 meter. So that F2 minus F1 equals Q rho quantity V1 minus V2. And F2 is, so imagine this is depth 2. F2 consists of rectangle and triangle combined. So F2 is specific weight. For the rectangle, if this is depth 2, then barred H is depth 2 over 2. The area is 3 times depth 2. So that's for the rectangular part. For the triangular part combined, take note that x is 4/3 of depth 2 because this is depth 2. X is 4/3 of depth 2 plus 4/3 of depth 2. So 2x, therefore, the base of the triangular part is 8/3 of depth 2. So for the triangular part, 9.81, the location of the centroid of the triangle is 1/3 of depth 2, that one. Then the area is 1/2, base 2x, 2x is 8/3 d sub 2, height d sub 2. So we cannot combine because this is d sub 2 square and this is d sub 2 cube. So simplifying, F2 is 14.715 depth 2 square plus 4.36 depth 2 cube. So that is F2. For F1, on the other hand, so the depth is 1 meter. So F1, area 2 is, by the way, 3 depth 2 plus 1/2 of 8 depth 2 over 3 times depth 2. So that would be 3d sub 2 plus 4/3 d sub 2 square. That's area 2. So F1 is 9.81 times 0.5 for 1 meter depth. Centroid is 0.5. Then area is 3 times 1 for the rectangular part. For the triangular part, specific weight 9.81. Barred H is 1/3 for the triangular part. Then the area is 1/2 of 2x or 1/2 of 8/3 because x is 4/3 times 2, so 8/3 times depth 1. So we can combine. F1 is equal to 19.075 kilonewtons. This is also in kilonewtons. So substitute now. Area 1, by the way, is 3 times 1 plus 1/2 of 8/3 times 1. Or 3 times 1 plus area of triangle 1/2 of 8/3 times 1, that's 4/3. So 13 over 3 square meter. So 14.715 d sub 2 square plus 4.36 d sub 2 cube. Then minus F1 19.075, substitute here, equals 25 times density of water. We divide 1000 because the left side is in kilonewtons. If you do not divide by 1000, the right side will only be in newtons. So to be consistent. Then discharge, V1 is discharge over area 1, 13 over 3, area 1, minus V2 discharge over area 2. Area 2 is 3d2 plus 4/3 d sub 2 square. So simplifying, 14.715 d sub 2 square plus 4.36 d sub 2 cube. Then 25 times 25 is 625 over quantity 3d sub 2 plus 4 thirds d sub 2 square. So that becomes plus because that's negative. It transfer it to the left. Then negative 19.075 minus 25 square over 13 over 3. That's negative 160.306 equals 0. So again, we can solve this by trial and error only or by your high-tech calculator. So solving for d sub 2 by the high-tech calculator or by trial and error, it will take time. 2.176 meters. Then that's the depth after the jump. The Froude number is FR2, velocity 2 over square root of G, hydraulic depth at section 2, which is area 2 over top width. So B at section 2 is 3 plus 2x. 3 plus 2x, and x is 4 thirds of depth 2. So the top width is 8.803 after the jump. Then area 2 this is area 2, 3d sub 2 plus 4 thirds of d sub 2 square, where d sub 2 is 2.176, so 12.84 square meters. Substitute. By the way, V2 is discharge over area 2, so 1.947 meters per second. So FR2 is velocity 2, 1.947 over square root of 9.81, area 2, 12.84, top width 8.803. So remember, Froude number for non-rectangular section, velocity over square root of G hydraulic depth, where hydraulic depth is area over top width. So Froude number 2 is 0.5147 because FR1 or this one occurs in the lower stage. So if you compute FR1, it should be more than 1. So this is after the jump, expect less than 1 Froude number or subcritical flow. Then the percentage dissipation, that's head loss over specific energy 1 times 100%, where head loss is specific energy 1 minus specific energy 2. So V1 is Q over area 1, 5.769 meters per second. So specific energy 1 is 5.769 square over 19.62 plus depth 1, that is 1. So 2.696 meters. Specific energy 2 is V2, 1.947 square over 19.62 plus depth 2, 2.176, 2.369 meters. So remember, head loss is E1 minus E2. So percent dissipation is quantity 2.696 minus 2.369 times 100% over E1 2.696. So percent dissipation therefore is 12.13%.